All right, so a graph we said is X controls, right? So X controls the graph, that's the input, that's the independent variable. Y just behaves based off of how you're controlling it. So your only thing that you have to worry about is where are you moving on the x-axis. So if you're moving to the right or you're moving to the left. From there, it's kind of like an etch-a-sketch. If you think about etch-a-sketch, you're all over one of those. You move one control, that moves it left and right, and then the other one controls up and down. Well, I really suck at etch-a-sketch. What I really wish that I moved the one and controlled the other, because then I get my free picture on it. So that's basically what a graph does. So what we want to say on this picture here is as we move towards this x value, you guys now see, okay, I move up, then this is my y value at that x point. That gets you the ordered pair x, y right there. And as you move towards this x, that tells you how the function behaves off the y-axis, right? Does that make a little bit more sense now? Right. So the definition of a limit, you guys have seen this, the limit of f of x. So we're wanting to know how is the function behaving, so that's the limit of that function means, as x is approaching a value a. Because remember, you can only control x, you cannot control y. So how is the function basically behaving as x is getting closer to some value a? Whatever that value is called L, that's the limit. Okay, so in words, it's the limit. Yes, ma'am? Yes. Yes, this actually today is mostly review. Tomorrow, we'll get a little bit. A lot of the, you had the main pieces of it last year in pre-calc. We're going to get a little bit more specific and make sure you know how to do it. You're going to get a little harder problems this year too, little different kind of thing. So the definition says the limit of f of x, so the limit of the function as x approaches a. Is L. So basically, as you work your left or right, okay, so you're just controlling that handle left or right, how is it behaving going up and down, is what you're after. So this idea of finding that ordered pair off of the graph is basically the idea of finding the limit. So here you have the function y is equal to x squared, or f of x is equal to x squared. So if you look at x is equal to 2, right here, f of 2 is equal to 4. So that's how you can find the ordered pair. That is the ordered pair, if you want to put that point on there, it is the ordered pair 2, 4. So then you ask what is the limit as it comes from there. What you have to see is, what is the function behavior as you're coming from values less than 2? Is it going towards 4? And as you're coming from values greater than 2, x values greater than 2, let me put it that way, your graph is going still towards 4. They agree from both the lower numbers and the higher numbers, so the limit there is 4. Now, from our stuff last year, you remember hopefully that it's not always that nice and pretty, sometimes those numbers don't agree, correct? So, if you look at the ones that don't reach their intended height, if you look at this one, I think you remembered also that if we just put this number in to the equation, that would give us that number out, right? Because that's what we did up here. We said, well, if you put in f of 2, you get out 4. If you put in 2 squared, that's 4, right? So that was the limit. Well, that would be really nice and easy, but look what happens. If you look at this one, if you want to find the limit as x is approaching 2, what happens to the denominator? 2 minus 2 is equal to 0. And last we checked, and you have 0 as the denominator. No. So that whole thing sort of breaks down. But what we can do instead is we can factor and reduce it. So 2 things that multiply together give me 8. But add gives me -6. -2 and -4. So x minus 2, x minus 4. And again, this is finally why we care. X minus 2 and x minus 2 can cancel. And so now, my denominator is truly a 1, so I don't really write it. If I substitute in 2 now, 2 minus 4 is -2. So we think the function for the limit should be -2, but let me make sure we remember this notation. As it approaches 2, and there's a little plus sign that's from positive values, or values greater than 2, because we're doing that. And what's the value as you get coming closer to 2 from the negative side or from values lower than it? Do you remember that or not? Okay, let's get a graph. You don't need a graph, that's all. So if I'm going to graph this thing, I'm going to make it x squared minus 6x plus 8 divided by x minus 2. You look at that, it almost looks like a line, right? So you're thinking, well, okay, so what's so special about this? But as I zoom in, let's go, 0, 3. Still, you can quite see it. Here's x is equal to 2. It's hard to see on here. There'd actually be like a little circle right there because you can't have 2.2 because that makes bottom is 0. But if I trace this, if I want the limit as x approaches 2 from the positive side, x values are just slightly lower than 2, right? That means you're approaching it from the lower side or the negative side of it. So as you look at it, I'm getting closer and closer to 1.978. I'm getting really close. My y value, or what should be my limit, is at -2.02, somewhere there. And as I'm looking at it, I trace it again. As I'm looking at it, as I'm looking at it coming from the plus side or the positive side, where numbers greater than 2, as I make it get closer, my s value gets closer and closer to 2. 2.07, 2.04, 2.01, I'm pretty close to it now, right? It has a value of -1.99, basically -1.99. Think of your tables from yesterday. If you had to say where would you round both of those to the nearest whole number, it would be -2. So does that make a little bit more sense of coming from the right side or the positive side or numbers greater than it? Okay, so maybe do it right up here. Give a limit as x approaches a from the plus sign. This is for things that are from this is from the right. Or another way to think about it is numbers bigger than a. And sometimes I even call that from the positive side. Because think about a number line, years and years ago, you used to draw all the positives over here. You put 0 in the center and draw the negatives over here, right? Okay. Now, you could still be working all in negative. So that's why sometimes it's just nice to think of it as being, I'm working towards that number from something that's bigger than the number I'm working towards, to something to the right of it. If you have the limit as x approaches a with a little negative sign, then you're working from the left or from numbers smaller than a, or you're working from the negative side. It kind of depends on which way you want to think of it. All of them kind of go together. They all kind of are the same thing. But remember, we're always thinking about the x-axis because we're always going that's the only axis we can control. We get a fixed yes, but then we are stuck with whatever happens with y at that point, because that's the dependent thing of things we can't control. So does that help that thought a little bit of what the little plus and little minus means? Again, so if we look at h of x equal to 1 over x, and we want to know what's the limit as x is approaching 0, again, think of this. If you put 0 in the bottom of x, you're going to get 0 in the denominator, can you have that happen? No. So that's a problem. So we look at it as coming from the positive side. So basically, if you think about this instead, we can't factor anything either. We're going to have to imagine for this. If I'm coming closer and closer and closer to 0, would you agree that the numbers like 0.1 and then 0, or 0.01, and then 0.001? And if you're taking 1 and dividing by a decimal, the number's actually getting bigger and bigger and bigger, right? This was an answer of infinity. And in here, infinity means that it's just getting really big, that you can't touch it, basically. If you think of the other one, the limit coming from the negative side or from the left side, it'd be these same fractions, but with a negative sign in front of them, right? So when the numbers keep getting really, really big, nope. 1 divided by 0.1 and then 1 divided by 0.0, that number keeps getting really, really big. But it has a sign in front of it. Negative, so it's getting really big, negative. It's going to be a really large negative number. So it's going to be a negative infinity. And it's weird because your book will use the terminology a large negative, or negative large or something like that. So it's still a really, really huge number, just happens to be a negative number instead. So if you look at the back,